This video covers the review sheet for test number 4 for AP Calculus. It covers position, velocity, acceleration, implicit differentiation, and related rates. Let's start with number 1. Find the average rate of change of y with respect to x on the interval -1 to 2, where y equals 3x squared plus 4x minus 1. Anytime you see the word average attached to any sort of derivative, whether that be rate of change, velocity, acceleration, derivative, then you need to use the slope formula. You actually don't take any derivatives at all, you just do the slope formula. So I take the -1 and plug it in my equation. So y equals 3 times -1 squared plus 4 times -1 minus 1 gives us 3 minus 4 minus 1, which I believe is -2. Then we plug in the other equation, the other point, which is 2. So 3 times 2 squared plus 4 times 2 minus 1. 2 squared is 4 times 3 is 12. 4 times 2 is 8 minus 1 gives us 19. So we have the ordered pair -1, -2, and 2, 19, giving us 19 minus -2 over 2 minus -1 for a total of 21 over 3, or 7. So the average rate of change, also meaning the slope between the endpoints, is 7. Number 2, if the position function, I apologize, these should be t's right here, 2t cubed and 4t. If the position function is s of t equals 2t cubed minus 4t, what is the velocity of the object at time 1? So notice the difference between question 1 and question 2. Question 1 asks for an average over an interval of time. This is asking for something at one specific instant, and that's when we take the derivative. To get from the position function to the velocity function, we take the derivative, giving us 6t squared minus 4. And it wants to know what it is at time 1, so we plug in 1. So 1 squared is 1 times 6 is 6. 6 minus 4 is 2. So the velocity at time 1 is 2. Number 3, an object is dropped from 1,200 feet. When does it hit the ground, and what is the velocity at time 3? Our position function when we're dealing in feet and we're dealing with gravity is -16t squared plus v naught t plus s naught, where v naught, that's the v with the 0 subscript, is the initial velocity and s naught is the initial position. Well, if something is dropped, its initial velocity is 0, so we won't have a middle term in this one at all. And it's 1,200 feet high when it drops, that's its initial position. So our position function for this would be -16t squared plus 1,200. Part A says, when does it hit the ground? Well, at the moment it hits the ground, it would have a position of 0. So I'm going to take the position function and set it equal to 0. I can then solve for t. I'm going to add 16t squared to both sides. Divide both sides by 16. I get t squared equals, let's see, 1,200 over 16 would be 75. So we get t squared equals 75. So t is equal to the square root of 75, which if you want to reduce that should be 5 square root of 3. That's also about 8.660 seconds if you have it as a decimal. So the answer to A is 5 square root of 3, or about 8.660. Then B says, what is the velocity at time 3? So to find the velocity at a specific time, we take the derivative. So I'll do this in red. We need to take the derivative, so velocity is -32t. And we plug in 3. -32 times 3 gives us -96. And that would be feet per second. Next, an object is thrown straight down from a 300-meter building with an initial velocity of 15 meters per second. We're dealing in meters, so we would do negative 4.9 t squared plus v naught t plus s naught this time for our position function. 300 meters is our initial position. So let's see, ask for our position function, negative 4.9 t squared. We know 300 is going to be our initial position. It says it's thrown downward with an initial velocity of 15 meters per second. Since it's thrown down, that initial velocity is negative 15 seconds, or negative 15 t. So if it's thrown downward, it's going to have a negative sign. Then part B says, what is the velocity at time 2? So I take the derivative of the position function. That gives me the velocity function. And I plug in 2. Negative 9.8 times 2 minus 15 gives us negative 34.6. Number 5, a coin is dropped from a height of 500 feet. We're dealing in feet, so we know we do negative 16 t squared. It's dropped, so its initial velocity is 0, so I won't have a middle term. Its initial position is 500, so that's my height. B says find the average velocity on the interval 0 to 2. Again, when you see average, you don't do any calculus, you don't do any derivatives, you just do the slope formula. So I plug 0 in the original, that gives me 500, and I plug 2 in the original. See, negative 16 times 2 squared plus 500. So that's negative 16 times 4 plus 500. We get 436. So we do the slope formula, 436 minus 500 over 2 minus 0. That's going to be negative 64 over 2. Let me double check that, but I think that's right. Yep. And so we get negative 32 as the average rate of change. Again, average, you do a slope formula, no derivatives. C, find the instantaneous velocity at time 2. This is when we do a derivative. When we're over an interval and doing the average, we do the slope formula. When we are doing it at one specific point, we do the derivative. So the derivative of this equation is just going to be negative 32t. So we're taking the derivative of this equation, the position function. Then we plug in 2. Negative 32 times 2 gives us negative 64, and it would be feet per second. Part D, how long does it take for the coin to hit the ground? We know when it hits the ground, it will have a position of 0. So we set the position function equal to 0. I'm going to add 16t squared to both sides. Divide both sides by 16. Gives me t squared equals 31.25. Then take the square root of both sides. I get 5.590. That's my answer for D. That's how long it would take to hit the ground, 5.59 seconds. E, what's the velocity at impact? So again, we're looking for the velocity at a specific time, so we use the derivative, which is the velocity equation, and we plug in our time, which is 5.590. We get negative 178.885. Okay, next question. Find the derivative. The next few are all chain rule. This is just hopefully a reprieve from all the word problems to have some just chain rule problems. But also chain rule is what's really behind our related rate problems and implicit differentiation. So that's very closely related to our big topics. Remember, with the chain rule, you do the derivative of the outside, leaving the inside alone, times the derivative of the inside. So our outside function here is that power of 5. So I do the multiply by 5 Subtract 1 from the exponent. That's my derivative of the outside. Notice I have not touched the inside. I leave it alone. Just do the derivative of the outside part only. Then I multiply by the derivative of the inside, which would be 6x squared minus 8x plus 7. And the only simplifying you can do is to multiply the 5 times this piece over here. So you could have 30x squared minus 40x plus 35 times 2x cubed minus 4x squared plus 7x to the fourth. So that would be the best answer. I would accept the one above that. It's not simplified, but this is the best answer. 7. Find the derivative. The simplest thing to do here is bring out the 2x plus 4 as 2x plus 4 to the negative 1, and then use the chain rule. We multiply by negative 1, subtract 1 from the exponent, then multiply by the derivative of the inside, which would just be 2. Now that answer is fine, but you're more likely to see them go ahead and do negative 1 times 2, which is negative 2, and put that 2x plus 4 back down on the bottom and give it a positive 2 instead of a negative 2 exponent. But either of those are acceptable. Number 8, still taking the derivative. This is another chain rule problem. One thing that might help you, t over 3 is the same thing as 1/3 t. Think about it. Dividing by 3 is the same thing as multiplying by 1/3. Our outside function is the secant. So we take the derivative of secant, which is secant tangent. Notice I left the inside alone. I haven't changed it. Then we multiply by the derivative of the inside, which would just be 1/3. You can bring that 1/3 out front if you want. Pretty much the same thing either way. Number 9, we need to rewrite this equation as 2x cubed minus 5x raised to the 1/4 power. So for the derivative, we multiply by the 1/4 because we're taking the derivative of the outside, which is the 1/4 function. Subtract 1 from the exponent, then multiply by the derivative of the inside. Again, all you can really do is multiply this coefficient out front by this back here. 6 times 1/4 is 3/2. 5 times 1/4 is 5/4. And if you want, you can bring that 2x cubed minus 5x to the bottom and write it to the positive 3/4, but we'll just leave it right there for our purposes. Alright, one more and then we'll put the rest of this on part 2 video. So we find the derivative. The outside function is cosine. The derivative of cosine is negative sine. We leave the inside completely alone. Now we multiply by the derivative of the inside. We get 33x squared minus 4. And if you want to bring that out front and apply the negative to it, you can. Doesn't really matter to me either way. Okay, the rest of these will be on video number 2 or 3 if I have to do 3. So check those out.